We are in Unit 2, Lesson 4, titled Bohr Diagrams, and our objective for this lesson is that students will be able to draw a proper Bohr diagram for any of the first 20 elements. So Bohr diagrams are actually named after the man who did the research to discover a more accurate model of the atom. His name was Niels Bohr. Here's a lovely picture of him. And he built upon Rutherford's model of the atom. So here is Rutherford's model of the atom. Recall that Rutherford said that there is a dense center of an atom called a nucleus that has protons and neutrons, and that electrons fly around the nucleus in random paths in empty space. So what Bohr said is he actually said that that model was not consistent with the chemical properties that we saw of atoms. So he, based on his research, found that electrons can't really randomly fly wherever they want around the nucleus. They actually will only travel in discrete distances from the nucleus. He called these paths, these particular distances from the nucleus, energy levels. Energy levels is the major contribution that Bohr made to the model of the atom, so you should definitely make sure that you associate that with his name. So the benefit of being able to draw a Bohr diagram is that it will show you where the electrons are located within an atom, which becomes important when we want to talk about ions next, and then chemical bonding next, and then stoichiometry next. So it's the beginning of a lot of good things. So let's try to do a Bohr diagram for the very first element, hydrogen. And the first thing that you need to do when you do a Bohr diagram is figure out the number of protons, neutrons, and electrons. So good thing we know how to do that. So the atomic number for hydrogen is 1, which means it has 1 proton. And because I know that the atom is neutral, that means that it has 1 negative electron to balance it out. And if I round the mass number here to 1, and I subtract away the protons, I'm going to get 0 neutrons. So it is possible to have 0 neutrons. So once I figure that out, I'm going to go ahead and draw my nucleus. So I have one ready to go right here. Here's my nucleus. And inside of it, I'm just going to write how many particles I have in there. So remember, it's the protons, oops, that's a plus sign, that sit inside the nucleus. So there's 1 proton and 0 neutrons. All right? So that's the first thing you do. Then, when that's done, you go ahead and you add in your electrons. Oops. All right, there we go. So this right here is my first energy level. Remember, that's a vocabulary term that Bohr told us is an energy level. So this is where I'm going to place my electrons. So I have 1 electron, and it is going to sit on this first energy level here. And my pen is kind of thin, so it kind of looks like a funny circle. But that's all there is to it. So the first energy level can only fit 2 electrons, but since we only have 1, we don't run out of room. Alright, so this is the Bohr diagram for hydrogen. We're going to do another example next. So now we're going to do the Bohr diagram for lithium. So just like I did last time, I'm going to figure out protons, neutrons, and electrons. And again, I would pause me and try to do this yourself. So protons is 3 for lithium. We're doing lithium. Which means electrons are 3. And neutrons, I'm going to take 7 and subtract away the protons to get 4. So now I'm going to draw my nucleus. And inside of it, I'm going to put the protons, plus sign, and the neutrons, 4. Sorry, this is so messy. 4. And then I'm going to draw my first energy level. The first energy level can fit 2 electrons. So I'm going to draw 2 electrons. But I have one more electron left over here, so I have to draw another energy level. And I'm going to place my electron on that energy level. So I have 3 protons, 4 neutrons, and 3 electrons, 2 electrons on the first energy level, and 1 electron on the second energy level. And that is the correct Bohr diagram for lithium. Alright, we're going to do one more example here. We're going to do magnesium. So magnesium has 12 protons, 12 electrons, because it's neutral, and 24 minus 12 is also 12. That was easy. So 12 neutrons. So I'm going to be smart here, and I think I'm going to write the protons and the neutrons first, and then put my circle around it so it actually fits. Yay. And then I'm going to draw my first energy level, and I remember that 2 electrons can fit on the first energy level. And remember, if you want to try this before I give you the answer, you should pause me. And then I need another energy level. And how many electrons do I have left? 2. I have 10 electrons left. So 2 electrons can fit on the first energy level, but 8 electrons can fit on the next energy level. So I'm going to draw 8. 2, 4, 6, 8. Alright, so 2 plus 8 is 10, but I still have 2 electrons left. So guess what I have to do? I have to draw another energy level. And the last 2 electrons go in the highest, this last energy level. Alright, so that's a correct Bohr diagram for magnesium. Now, of course, because you are curious people, you are wondering why only 2 electrons fit on this first energy level, but 8 can fit on the next one, and 8 can fit on the following one. Well, it really just has to do with size. The first energy level is the smallest distance from the nucleus, and it's the smallest path, so it can only fit 2 electrons. Remember, electrons have negative charges, and negative charges tend to repel each other, so you can't put too many negative charges next to each other. They're like magnets, they push apart, so only a certain number of them are allowed within a particular energy level. That might be a great conceptual question on a quiz. I might ask something like, why do only 2 electrons fit on the first energy level? Or why can't all electrons fit on just one energy level? And you talk to me about how they have the same charges, and they repel, and so they won't all fit in the same area. So after this lesson, you want to make sure that you're able to use the term energy level properly to describe the particular distance electrons travel around the nucleus. You want to make sure that you're able to draw a proper Bohr diagram for any of the first 20 elements. After the first 20 elements, it gets a little tricky, and you should take AP Chemistry to find out why it's so tricky. And then finally, you want to be able to explain why only 2 electrons fit in the first energy level, and only 8 in the preceding ones.